in South Kona, very close to where I'm living, right below where KCOF was. And he had a papaya orchard, and the papayas were, way too tall. And I met him, and I was talking to him. And it was actually the first crop that I actually learned how to grow. I started helping him in his field, helped him harvest. He was just an old Filipino guy, and I was pretty good at catching things. And I'd help him harvest his papaya, and he would tell me about papaya. And the problem was he was cutting down trees because there was a ring spot problem, and it was mosaic. But he had pulled off his crop. It really didn't start affecting him until he had already gone a year or two. And he was abandoning it. And he explained to me that most of Kona was papaya 5 or 6 years before. And it was where most of the papaya was being grown. But now everybody was moving over to Puna. And we're going to grow it in Puna because they didn't have any papaya over there. And they could grow it successfully. And then he said at a certain point he was over harvesting. So I just was given free reign of the orchard. And I every week would go over there and get myself a case of papaya. And that's what I ate, and chopped down trees that had ring spot on them, just to keep it going. And I never thought about it really again. It was just papayas were everywhere. Papayas, and there really was very little ring spot. You didn't really see it. It wasn't really a big deal. And then I started growing papaya. When I got my land, obviously, it was one of the first things I started growing. It actually was one of the major sources of income. I was making $200-300 a week just off my papayas. I was just a hippie. I planted my fields. They weren't really producing. I put papayas. I had about 20-30 trees, maybe 40 trees. I was making almost $200 a week with my papayas. I was drying the ones that weren't beautiful, and I had beautiful papayas. Never even gave a thought to it. Never had a problem. And people started talking about ring spot and this spot, and there was all different kinds of diseases, obviously. There was black spot, and there was the chocolate spot, and there was a few phytophthora sometimes, and root diseases. But if you direct sowed your papayas, usually did pretty well if you had plenty of sun. And back then it was a lot of rain, and we weren't thinking about it too much. But then they started talking about the GMO in the 90s. About 10 years later, after I got my farm, they started talking about how horrible this virus was. And I don't remember it being so bad. And I went over to Puna and was talking to people, and really by then I had pretty much figured out how to grow things and stuff. When we developed a system to protect against ring spot. It was basically creating a kind of a coating you put on your plant, because there was research coming out of Clemson University that humic acids would block the transmission of they would cover a tobacco plant with humic acid. A liquid humic acid, a teaspoon in a gallon of water, and spray it on the tree. Then they would take a sand gun, and in that sand gun, very, very superfine sand, and they would put tobacco mosaic virus. Mm-hmm. And they would shoot treated and untreated tobacco plants with it. And the only trees that got infected by the virus was the ones that hadn't had the humic acids put on it. And that goes back to an earlier concept that I was using at that time, which was a biodynamic concept of using, highly composted, really like a manure tea, and spraying manure tea on trees, and spraying yogurt on trees so they could resist diseases and viruses. It's an old biodynamic trick, and an old farmer trick, using manure. They actually painted manure on young bark and stuff like that, on young trees, and sprayed all these different things. And actually, 2 years ago, I think there was some research, I forget the university, but they found that elements, in yogurt and stuff like that, certain common bacteria, spread the transmission of viruses. And we see that in our health. We see the people that are eating correctly and are eating fermented foods and stuff like that maybe don't get viruses, get diseased as easily. And so when I was working with the papaya guys, because we were trying to figure out why is one field have virus and not, we realized I did dozens and dozens of tests. I did put on a number of workshops teaching these guys how to do it organically and stuff, and with all the concepts. But the glaring thing that came up was that a field that had a lot of virus had a very, very little calcium in it. Now, calcium equals roots in growing plants. Papayas have very fragile roots. That's why papayas usually you want a direct seed, and you don't want to disturb the roots too much. And they get a lot of root diseases. So calcium, it made sense that the less calcium, 1,000 pounds of calcium per acre is kind of what you want to have a healthy papaya tree. If you once it goes down to below 100, that's where the viruses come out. Now it turns out also there's other variables that these guys would basically clear the rainforest, the low-level virgin rainforest. They would just basically push the top 6 inches off it in Puna, and they would create these kind of buffer zones of rocks and trees and stuff around 20 acres. And they do these 20-acre squares. And then they plant directly in those fields and just use 1616 basically. And 2 or 3 years later, the trees would get a little bit tall, still could be harvested, but most of them were really diseased by that point because they never put any calcium down. So basically they just exploited, used up all the calcium that was in the soil, the trees got sick, they'd cut the trees down, and move on and plant again, and then by the third time they really couldn't get a crop off, and then they'd abandon the fields. Now that's how they were doing it in the 80s. Now the 90s, everything switched. They started getting disease right away, and this virus was a different looking virus than anyone was used to. But it turned out that this was the virus that these guys had created the GMO for. Now I believed at the time that these people that were created these GMO papaya actually infected Hawaii with the papaya with the virus that they had wanted. They had Hegelian dialectic. They created the problem. They had the cure, and in reading the literature of the Papaya Administrative Committee, I had some friends on it. Showed me a letter from the biotech industry thanking the Papaya Administrative Committee, who were basically a committee that was mandated to create a situation where people could sell their papayas. So they had a grading system and oversaw it, and that's why Hawaiian papayas were really the state of the art in the world at that point. But the Papaya Administrative Committee was basically taken over by the biotech guys in the early 90s to promote the GMO papaya. And I saw a letter thanking them and saying that the investment into the Papaya Administrative Committee and all the people in the which amounted to millions of dollars, was well worth it because by the Big Island accepting and the people accepting GMO papaya, it would be easier for them to sell their GMO corn and soybeans and stuff like that. They called it an orphan crop. So it was basically a throwaway. It was like, they threw a few $1 million at some scientists and professors in Hawaii. They took over the administrative committee. They stopped all research on papayas, where we could have had a field of papayas and let them grow. And after 3 years, we could cut down every tree that had virus. And the trees that were left, we could use them for breeding. And eventually, we could have probably had a naturally bred papaya that could have resisted it. But what they started doing in the 90s is they stopped cutting down the virus trees. They just let the virus trees grow in Puna. So pretty soon, Puna was covered in abandoned virus fields. Made it absolutely impossible for anyone to grow papaya anywhere on the islands, because it was almost like they just contaminated the entire island with virus. So by the time the GMO papaya was released, so I think it was 97, they had already contaminated most of the strains of papaya. In 95, I did a research project, and all of my seeds that I got from my friends were already GMO'd. This is 2 years before they were even released. So they were releasing them years before they even were supposed to be releasing them. Absolutely unbelievable. I mean, I think it was total criminality, but, when I start thinking that way, it's crazy. But then I heard some testimony by a plant geneticist at our hearings here, who said that their studies showed that the papaya, the GMO papaya, the virus that's on the islands for that GMO papaya is a different virus than we had in Kona and originally in Puna. That literally we were infected by the biotech people with a virus that didn't exist here, that now they've created a GMO papaya to save us from. Now, they say our yields are up, but the price is down. We have less papaya farmers. We're growing less papaya now than we grew in 1980 on the Big Island. Yet they say they save the industry. We have less papaya growers. Most of them are all large growers growing into the unlabeled market. I think it's a travesty because I'm going to get back to what a GMO papaya is. They have a cassette, and in this cassette they have the traits that they want to confer. In this case, it's a virus. Then they surround that with another virus from a cauliflower mosaic virus, a gene they found in that virus that is a gene that turns on. It's an on switch. So whenever that gene is put into something, all of the genes around it are turned on. Because a lot of our genes aren't turned on. They turn on not randomly, but specifically at growth points in our life. So certain genes turn on when you're little, they turn off, then the other genes turn on. So all our genes aren't firing at once. What this cauliflower mosaic virus makes all the genes turn on all the time. So everything's expressing itself. Then, because this technology is an old technology, they would never allow this now. The biotech guys I talked to, and I did talk to them, who developed the original technology to create insulin in the laboratory, which is the same technology they're using now in creating these corn things. They're a little bit more sophisticated now. They have RNA. They have genes that turn things on and off. I mean, they're way more sophisticated now. But when we're talking about papaya, we're talking about a 30, 40-year-old technology. So in the laboratory, they never knew because they didn't insert the gene. Some guy didn't sit there with a microscope and insert a gene into a nucleus and then grow it out. I mean, they want you to think it was that way. No, they had basically what they called a gene gun. And these cassettes of genes, which I'm going to finish telling you what the cassette is now, it had genes for antibiotic resistance. They had 4 or 5 genes that conferred antibiotic resistance to 4 or 5 different of commonly used antibiotics. Basically, in that combination, they would kill anything, any cell, any small cell, okay? And because in the laboratory, when they shot the gene gun, they never knew whether it took. So they would shoot the gene gun at a petri dish of millions of cells, okay? Mm-hmm. And they'd let those cells start growing, right? And then they'd wash the petri dish with 4 or 5 of these antibiotics. Tetracycline's one of them, penicillin, things that everyone uses. So, and basically that would kill everything except where that antibiotic-resistant genes were expressing themselves. Okay. So now 4 or 5 out of those million are now still growing. Now they're really sure they've got some cells that actually took. They got close enough to the nucleus. They're not quite sure whether they're growing the expressions they need, whether they'll grow into a plant or a fish or whatever it is they're trying to grow. But they're sure they got the genes into the nucleus. Now they grow it out, okay, and tissue culturing and stuff like that. And eventually they make a plant, and the plant's growing now. Now they want to test to see if it's actually expressing itself too. They want to see if it's still in full expression. So they inserted another gene called the beta-glucuronidase gene, which is a gene that creates an enzyme called beta-glucuronidase. And beta-glucuronidase destroys glucuronic acid. And it turns out in papayas, glucuronic acid, we have glucuronic acid in our bodies. In fact, one of the reasons we eat papayas is for the glucuronic acid, because glucuronic acid is a cancer scavenger. When glucuronic acid touches a cancer cell, it kills the cancer cell. So, they go, oh, it's no big deal, just a little extra beta-glucuronidase, maybe, kills a few glucuronic acid molecules. No big deal. Okay? No big deal. Okay, so we have that's this set of genes now is in a papaya. So when you eat this papaya, these genes are very unstable, and there's a concept called horizontal gene transfer. Every one of those genes can transfer into a gut bacteria, into a soil bacteria. So you eat one of these papayas, that beta-glucuronidase gene could transfer into your gut bacteria. Now your gut is producing beta-glucuronidase. Now you have no more glucuronic acid in your body, which was the major
symptom of that?
Cancer.
I see.
Increased chance of cancer.